Hello, welcome to all. Today we are going to start matrix multiplications. In matrix multiplications, we have taken any order of multiplications can be multiplied if it is compatible to multiply. Let us suppose matrix A is a matrix, it is written in the general format Aij, its order m cross n, and another matrix is B and its general element Bij and cross P. So here for the matrix multiplication, it is necessary that if I multiplied AB, A the prefactors, B the post factor, A and B. So we have this. They are necessary that row of matrix B. So there are the necessary condition for matrix multiplication is the number of row should be is equal to number of column of A, and this is for B. So this is the necessary condition. The number of rows of B is equal to number of columns of A. It only multiplied. Here you look here. Here it has m rows and n column. And in the matrix B it has n row and P columns. The number of rows of B matrix should be equal to number of columns of the A matrix. Now our matrix becomes Cij. So here the orders can be written like this: m cross n. First matrix has the order m cross n, and matrix B has the order n cross P. Okay, so here these two terms are the same. So our order becomes now m cross P. Okay, so m cross P, m rows and pth columns are the resultant of the matrix AB. So we can write this in the general format: Cijth element of this ones, and this is m row cross P column, m rows P column. So in this way, the matrix multiplication is compatible. It possible only when this condition is hold. Now there is some properties of matrix multiplication. Before that, we can go in one examples of the matrix multiplication of 2 cross 2. Let us suppose the matrix A had the element 3, 4, 2 and 1, and matrix B written in the format of 4 minus 3, and this is 5 and this is 7. If I multiplied A cross B, we have need to calculate AB. So here check out here. Here the number of rows is 2 cross 2. Its order is 2 cross 2, and its order is also 2 cross 2. Our resultant becomes, okay, here the number of columns of the prefactor, that is A, which is 2, and the number of rows of the post factors, B known as the post factors, and A the prefactors, both are equals. So our orders of A cross B becomes 2 cross 2 again. So 2 cross 2, 2 rows and 2 columns. So let us begin the first terms, how to calculate this ones. So this is first row, taken the first row and first column. Our element become here first row, first column. Let us suppose we have written it like Cij C11, first row first column, and first row second column, and second row first column, second row second column. These are the elements of AB. Okay, so this product becomes C. See the product of AB, C11. How to calculate C11? So we have to calculate C11 taken first row. If I calculate from this one C11 taken first row from matrix A, first row from the matrix A, and second first column from the matrix B. taken first row from here, and first row multiplied with the first column of the matrix B. So we have to multiply this is the first element will be here. So we have just multiplied the elements and then adding all these elements. Okay, C11. So here 3 cross 4, 3 cross 4, first element will be 3 cross 4 plus 4 cross 5. This is the first row, first column element. Now for the second row, second row, if I calculate this value, second row in first column, we have taken second row of the A matrix, and 1 for the 1 C1 the first rows. So we have to taken second row, this is the second row and first column. If I multiply 2 cross 4, 2 multiplied 4 plus 2 cross 4 plus 1 cross 5, 1 cross 5. This is the element, this one. Now we have to calculate this element. This is the element, first row and second column. We have taken 3 4 and 3 4 and this column. So 3 into minus 3. So this element becomes 3 into minus 3 plus 4 into 7. 4 multiplied 7. This is the element of this one. Now second one, we have to calculate this element. This is the second rows and second column. Taken second rows of A and we multiplied with the elements of the second column of B. So here the second row and first column, we have to multiply this and with this. So here 2 cross minus 2, 2 cross minus 3, and we have to add 1 cross 7. So if I simplify this one, this value comes out 14. 3 into 4 is 12. 12 plus 20, and here 2 into 4 is 8 plus 1 into 5 is 5, and 3 into minus 3 is minus 9 plus 4 into 7 28, and 2 into minus 3 is minus 6, and 1 into 7 is 7. So finally it becomes, if you simplify this one, 20 plus 12 is 32, and 28 minus 9 is 19. This will be 19, and 8 plus 5 is 13, minus 6 plus 7 will be plus 1. So in this way we get a 2 cross 2 matrix. So so it is necessary for the matrix multiplication. If you multiplied 2 matrices, so this condition should hold. The number of columns of matrix B should be equal to the number of rows of column B should be equal to number of column of A. So this is the necessary condition. These should be equals number. It means that number of columns A, 3 factors, should be equal to the number of rows of B. So it only possible. Let us go now properties of the matrices. Yes, I am again explaining one term. This one, if you calculate C11 first row, this is the first row and first column element. We have to take first row of the matrix A and first column of matrix B. This is, if you calculate this element, so this row should be multiplied with the corresponding elements of the first column. So 3 into 4, this is the value, 3 into 4 plus 4 into 5. So this will be our, and if you calculate this element, this is the element C12. C12 means first row second column element, taken first row from A and second column of B. So here the first row, this is the first row, taken first column. So 3 into minus 3 will be this, and 4 into 7. 4 into 7 will be here. So if you calculate this element, this is the second row and first column element, taken second row from A, second row, this is the second row and first column. If you multiply second row and first column will be this element C21. So 2 into 4 this will value, and 1 into 5 will be this one. And last one, if you calculate C22, it will be the second row and the second row of matrix A multiplied with the elements of the second column of matrix B. So it means that this is the second row and second column. So 2 into minus 3 will be this, plus 1 into 7 will be this one. So if you calculate this value comes out this one, and this is the final result. So final results we have matrix A. This is matrix A and matrix B. Matrix A had the order 2 cross 2, and matrix B had the order 2. Matrix B also 2 cross 2. So this will be not taken. So these should be equal to, final order will be 2 cross 2. So that's why it is the order of 2 cross 2. So for every matrix is possible. So only if the matrix of, suppose if I take the orders of A, matrix A has the orders of, let us go 3 into 5, and matrix B taking the orders of 5 cross 6. So here you look here. So here AB is possible only, BA not possible. AB is possible because, so here in AB, number of rows of A, not number of columns of A. Number of columns of A should be equal to the number of rows of B. So that's why its order become finally 3 cross 6. 3 cross 6 will be the order of A cross B. But A, B not possible. It is not possible because the reason is, if I take BA, so for the BA you should have number of columns of B. Here number of columns of B 6, and number of rows of A which is 3. So 6 or 3 not equal to, so BA not possible. So B not possible, but AB is possible. So only. So now we go for the matrix multiplications and some properties of the matrix multiplication. Now in this case, matrix multiplication is not commutative. Suppose it is not necessary that the product of AB, so this is the product of AB. If AB is defined, BA is also defined. Okay, so BA is also defined. So it is not necessary that AB should be equal to BA. So sometimes it comes out, in some cases there would be AB equal to BA, but in all cases AB will not be equal to BA. So we can say that matrix multiplication is not commutative. So so for this AB and BA should be defined, but AB and BA has not the same value. And second point we have, if the multiplication of two matrix, zero matrix, it means that zero matrix add the product of two non-zero matrices. So another point is, suppose if ABs are two matrices and AB can be 0. AB two matrix, product of two matrix is 0, and here A, it is possible that A is not 0 matrix and B is also not 0 matrix, but their product is equal to 0. So it means that it is possible only. Okay, in normal case, in normal multiplications, if I multiply two values, okay, in normal algebra, okay, these are the product of two elements of algebra. If xy equal to 0, it only possible that either x equal to 0 or y equal to 0. Okay, either x equal to 0, y equal to 0, it only possible. But in case of the matrix, so A and B are the matrices. Matrix multiplications can have 0 matrices. Okay, and here A is not equal to 0, B not equal to 0. Now in the second property we have seen that when two non-zero matrix, if their product comes out 0, it is possible in the case of the matrices. Now third property of the associative laws. In associative laws, so if we have three matrices A, B, C, A, B, C are the three matrices. So A, B and C are the three matrices. So respective orders should be defined for the multiplication. So we have A, B, C. So A, B, C should be equal to A, B and C. It is only possible if the left hand side and right hand side should be defined. Okay, defined for the multiplication. It is at the case of the multiplication. So we have, if I multiply A, B, the rows of B should be equal to the columns of A. It only possible. So it should be defined. If the both left hand side and right hand side is defined, then these should be equal to. So this is the associative law. Now we have the fourth case, the distributive law. The distributive law, we have in the distributive law, this taken, let us suppose taken three matrices A, B, C. A, B, C are the three matrices. So here A dot matrix multiplication A refactor A plus B plus C equal to AB plus AC. So this will be equal to this only if it is defined. Okay, left hand side is also defined, right hand side also defined, because there is a multiplication factor. AB here, AB multiplied A and B multiplied A and C. So for AB, the rows of B should be equal to the columns of A. For AC is possible so only when the number of columns of A should be equal to number of rows of C. Similarly, B plus C should have the same orders, and the number of columns of A should be equal to the resultant of the number of rows of resultant of B plus C. So it only possible the distributive law known as multiplication is a distributive over additions. Now in the second part, if I take A in right hand side is also possible, B plus C and A is taken out A, and if I simplify this one, BA plus CA, BA plus CA. So it only possible, this is distributive law only holds if the left hand side and right hand side should be defined for the multiplications. Now our fifth rule is fifth properties of the matrix multiplication, the existence of multiplicative inverse. So for every square matrix, there is an existence of the multiplicative inverse. So we represented I the multiplicative inverse. So I2, generally I2, its order is 2 cross 2, and if I take I3 is simply I3 is equal to I3 means its order is 3 cross 3. So this 3 subscript represent order. So for every square matrix, there is an existence of identity matrix. So here, so let us suppose A is a square matrix. Of order is 3, and if I multiply A with I should be equal to matrix multiplication. Here commutative will possible I into A only for the matrix multiplication, commutative with only identity matrix. So it comes out A. So here I the identity matrix. So here the orders of A, order of A should be equal to the order of A. So here it only possible if order of matrix A is equal to order of identity matrix I, and both should be a square matrix. Both should have the square matrix. These are conditions also, square matrix. It only possible with the square matrix, not any order of matrix. So these are the properties. Let us discuss some questions, some important questions of NCERT exercise. Now, yes, this is the question, exercise 3.2, question number 1. Let us do one part of this ones. Third part of these questions. We need to calculate 3a minus c. 3a minus c. So put the value of, we have to multiply every element from matrix A with 3. So here 3 and matrix A is 2 3. 2 3 4 2 is the second column, minus matrix C. Matrix C has the minus 2, 3 and 5 and 4. So yes, if I simplify this one, so we have to multiply these elements of matrix A by 3. 6, 3 into 2 6, 3 into 4 12, 9, and this is 6, this is minus 2 and 3, 5 4. So we have to subtract. For subtraction, you look at order of these two matrices are the same, so it is possible to subtract. 6 minus will be plus 6 minus into minus will be plus, and 12 minus 5 9 minus 3 and 6 minus 4. So now if I simplify this one, this value comes out 6 plus 2 is 8, 9 minus 3 is 6, and 12 minus 5 is 7, 6 minus 4 is 2. So we get the value of, this is the value of 3a minus 3. Now take one example of the matrix multiplication of question number 3. This is the sixth part of question number 3. If I take question number 3, we would like to take some difficult and different type of questions, so that concept will be clear and you will be able to solve all questions.